Welcome to our video on ethical hacking. This video is part of a 3-session series focusing on securing technologies, people, and processes. This series reinforces the necessity of network security through the lens of the OSI model and defense in-depth principles, which emphasize securing technology, people, and processes. Session 1 focuses on network layers and security, serving as a preface to ethical hacking. We will cover definitions, network vulnerabilities, the OSI model, and an overview of vulnerabilities across all 7 layers. This session on network layers and security is presented by Dr. Data. The goal of ethical hacking is to find system vulnerabilities before they are exploited. This includes penetration testing, social engineering, and malware handling. The OSI model consists of 7 layers, each with specific tasks for data communication, similar to Adam Smith's division of labor. The OSI model defines 7 abstraction layers used by computer systems for network communication. Layers are categorized as host layers, 4 through 7, and media layers, 1 through 3. The OSI model layers are vulnerable to various threats. This slide lists common acronyms for reference across the application, transport, network, data link, and physical layers, as well as general networking and specific Linux and Windows commands. Here is a breakdown of common OSI layer acronyms and how they map to specific layers. Not every command perfectly aligns with just one layer. Everyday communication examples illustrate the function of each OSI layer, from web browsers at the application layer to cables at the physical layer. The host layers, 7 through 5, deal with software applications, data compatibility, encryption, and managing connections between computers, including authentication and authorization. The media layers, 4 through 1, handle data transfer integrity, packet routing via logical addressing, node-to-node transfer with data framing, and the physical specifications of the data connection. This slide provides a summary of various attacks and exploits that target different layers of the OSI model, from malware to sniffing attacks and DOS attacks. The basic network structure involves internal and external DNS namespaces and requests. DNS is a naming system that converts domain names to IP addresses, operating across OSI layers 3, 4, and 7. This slide reviews everyday vulnerabilities and attacks for each OSI layer, emphasizing that ethical hacking is an evolving art and science that goes beyond technology. Physical layer attacks include cable tapping and signal interference. Human errors and inefficient processes, such as poor cable management, exacerbate these issues. Mitigation involves encryption, sensors, and monitoring. Data link layer attacks include MAC spoofing and ARP spoofing. MAC spoofing allows attackers to mimic an address to gain unauthorized access. ARP spoofing tricks devices into sending communications to the attacker. Misconfiguration and failure to update firmware on network switches are human errors that create data link layer vulnerabilities. Inefficient processes, like poor documentation, can lead to security gaps, as seen in the 2016 Bangladesh bank hack. Network layer attacks begin with network scanning to reveal weaknesses. IP spoofing involves creating packets with a false source IP address to impersonate a trusted system, often bypassing IP address authentication. ICMP flood attacks overwhelm servers with ping requests. ICMP is also used for information gathering, including OS fingerprinting, which helps identify the target's operating system based on TTL values. ICMP router discovery protocol can be exploited via spoofing to add bad route entries, leading to denial of service. The teardrop attack uses overlapping IP fragments, causing systems to crash or reboot during reassembly. Transport layer attacks include SYN flood attacks, which overwhelm a server by sending many SYN requests without the final ACK. This leaves connections open and compromises service availability. Session hijacking involves seizing control of a legitimate user's session using captured or stolen session IDs. Attackers exploit TCP/IP vulnerabilities to impersonate parties, intercept data, and inject forged packets. Mitigating transport layer attacks involves using VPNs, secure coding, and strong session management with MFA. Human errors like misconfigured TCP/IP settings and a lack of secure communication protocols increase vulnerability. Session fixation is a session layer attack where an attacker obtains a valid session ID and tricks a user into authenticating with it, allowing the attacker to hijack the validated session. A session replay attack is an active intrusion where the attacker records and replays a victim session to gain credentials. Mitigations include not using public Wi-Fi, setting the HTTP-only flag on cookies, and monitoring unusual behavior. Presentation layer attacks include malicious code execution and data injection/tampering. Phishing and SSL hijacking are common. Mitigation involves data validation, encryption, and input validation to prevent code execution. Cross-site scripting, or XSS, is an application layer attack where hackers execute malicious JavaScript within a victim's browser, often by injecting code into a legitimate website via phishing or persistent methods. SQL injection is an application layer attack that fools a database into processing a dangerous query. Mitigation requires validating input, using parameterized user entries, and avoiding dynamic querying. Ethical hacking extends beyond technology to include people and processes. Human errors and inefficient business practices worsen vulnerabilities across all OSI layers. Ping and traceroute are basic, useful CLI commands, though they can be unreliable or blocked. Specifying times for ping or checking for intermediate IP addresses with traceroute are helpful practices. Practice Nmap and Metasploit in a sandboxed environment, like try HackMe's attack box. Use the CLI interface for Nmap, which is a powerful tool with many commands.